Hi there, I'm Ha, and this is just another video of me solving a numerical problem. So let's begin. We need to find the path with the maximum goal. So we have a goal map, right? M by N size, a grid or a matrix, and each cell has an integer representing a map goal in the cell, and then zero if it is empty, right? So grid of I and J will never be negative, right? Because this makes sense to find negative goal. It's either empty or there's some goal in there, right? So we need to return the maximum map goal we can collect under those conditions, right? We never visit the cell with zero, right? Every time you're located in the cell, collect all goal in that cell. So if it is six, right, and we collect 6 unit of goal. From your position, you can work left, right, up, or down. So four neighbors. Cannot visit the cell more than one, and then you can start and stop collecting goal any position in the grid that has. Okay, so here's our example, right? 587 and then 090, right? So we have to visit the cell that have some value, right? Because we're not gonna visit the empty cell, right? If we start from six, right? Our sum gonna be six, right? Keep track of our math, right? Gonna be zero. If it's in the worst case, we're gonna have zero go, right? So we go down, right? That's our only neighbors. So now our sum is 14, right? Updated to 14. Right. Now we can go in three fractions. Right? Okay, and then we can mark the visited cell, right, at zero here, right? So the circle here mean that I set this to zero. And we can do left first search. So we can go to the left first, right? So so I'm not gonna be 19, right? 19. Update the max, right? And then we don't have any more neighbors here, right? Because this is zero, and then this is also zero, right? So our three neighbors are zero, one, two, three. Because we want to visit the cell zero. So now we return it back up. So we set this back to five, right? And then we continue. So now we can visit nine, right? So I'm gonna be 14 plus nine is 23, right? So we update our max, 23, right? Now we are done. So we return back up. So we rewrite it with the original value, nine. And then we visit seven. So I was gonna be 21, right? So it's smaller, so we don't do anything. Okay. So we are done, right? So we return back up, right? And we finish visiting all three neighbors, right? So we return back up and rewrite the original value, which is 8, right? So now we finish our only neighbor, right? We finish process our only neighbor, so we return back up and rewrite the original value, right? So we have finished the first row here, right? So now we can start the second row, right? Look at the first. So we need to look at every single cell, right? And if it is not zero, then we want to try it out, right? So we start from five. Yeah. Our sum is five, smaller than the max, so we don't care, right? So we visit our only neighbor. So now it's 13. Okay, so we have three options, and we can go down. We just give us the sum 13 plus 9 is 22, right? Still smaller. So we are done now. Our neighbor is 0. So we return and we go this way. We resolve the original value. And we can go this way. This is 21. Or, oh, actually, it is 20. Right. still smaller, so we rewrite 7, and then try our last neighbor here, which is 19, right? Okay, so now we finished this and this, right? So now we try the next element, which is 8. Right now we go left, right, up, and down. Right, we have 4 possible na neighbors. Right, we're gonna give us the sum of like 13, 14, 15, and 17. Right, which is still smaller than the map. So I'm just gonna skip it for the sake of time. So here we can try this. Sum is 7. We can try our only neighbor, which is 8, so 15. Right, and then we can try 6, right, which is 21. It's still smaller. We return 5. Now we have 20, still smaller. We return. Right. We try 9. Now we have 24, right? Which is a new max, so we can update it here. Our max. Right, so we return. Right. So the reason that we were able to return is because the neighbors are 0, right? And this none is 0 because we marked the visited cell at 0, and we will rewrite the value when we return. So when we return, we rewrite the value here, right? And yeah, and I'm gonna try 9. You're gonna give us the same max, right? So that is our strategy. So we need to iterate through every single cell. So that is n by n. And then for each cell, right, we have to visit 4 neighbors, so 4 paths. And the recursion depth gonna be 4 to the n by n, everything, something like this. Right. So because we only have 4 neighbors, right? So that is 4 paths. So actually the n by n here, you can also put the number of cells that have the number of cells that is non-zero. So I mean like the path. So the number of go cells. So this one can be like 3, like the number of go cell. But in the worst case, every cell gonna be a go cell, right? So that for our space complexity, we have constant space, right? Because we update everything in place, but our recursion stack, right, gonna grow in the worst case and where we have every single element in the grid is a go cell. Okay, so that is pretty much it. Like code this up, right? So we're gonna have the row and column, column, right? Right. And then we're gonna have maximum to 0. We can return it at the end. We need to iterate in over every single row, every single cell. Okay. So we need to run the DFS, right, on each of the cell. We can ask in the row, the column, and then the sum, the current sum. We just start out at 0, row, column, and then the current sum. Okay. So if the row is greater than or equal to 0, the row is greater than or the column is greater than or equal to 0. Row is less than rows, and a column is less than column. So they are inbound, and then they have to be a go cell, right? So row and column have to be non-zero. If it is a 0, then we're not gonna do anything, but we just want to return. We're not gonna process it. Right? So select to make a copy right? Add the grid row and column, okay? And then we set the grid row and column, right, to 0 when we process it. And we need to set it back to the copy row. And now we can call our recursive function. So row -1, column, and then the sum, right? It is row +1. The column -1 and column +1. Right? So we will set the set to 0 to mark the visited, right? We're gonna set it back to the copy after we finish iterating through the neighbors here. Yeah. So before we call the recursion, right, we need to update our sum, right? So the sum here gonna be the sum of the original sum, the current sum, plus the current value, the current goal cell, right? Current number of goal at this cell, right? And we also need to update our max. Go to graph of max, of the max sum, and then the current sum, right? So yeah, that's pretty much it. We'll just try every possible path, right? And then keeping track of our maximum and work. Thank you for watching.